And when you start your job or when you start your business as a structural engineer, you have to see the what is the flow chart of output. So first, the very first day, you will receive the architecture drawing of any project. After that, you have to share them our structural framing plan with column and shear wall positions, analysis and design to freeze final member sizes, and then at the final stage you will issue the construction drawings with all required details at site. So this is the flow chart. Okay, now we will understand what is the loads acting on the structure. There are various types of load. See, we have gravity loads, we have lateral loads, we have longitudinal loads, and we have other loads. So in gravity load, there are three major loads: dead load, live load, and impact load. For lateral load, we have two loads: earthquake load and wind load. For longitudinal load, moving load is there, and for other loads like temperature or snow, whichever is applicable. So this is the load chart. We have to remember that there are four types of main load: gravity loads, lateral loads, longitudinal loads, and other loads. For detailing, first we have to focus three codes. First is IS 456 2000, second is IS 13920 2016, and third is SP 34. So why I have written SP 34? Because SP 34 is also very good for detailing conceptually. So SP 34 has to refer to all. So IS 13920 2016 is must for zone 3, zone 4, and zone 5. The structures which are lying in zone 3, 4, 5, we have to follow IS 13920. So we will start from load transfer path. So how gravity load will transfer to footing? So gravity load will transfer to from slab to from beam, from column, and then from footing. First element is RCC slab. So what is the meaning of slab, or what is the definition of slab? It is a structural element that is used to create flat horizontal surface such as floors, roof slab, and decking. Types of conventional slabs are: one is one-way slab and another is two-way slab. What is one-way slab and what is two-way slab? Those slab who transfer then majority of part in longer directions, so they span one way. Okay, so that's why which longer Ly by Lx, Ly is equal to longer span, Lx is the shorter span. When Ly by Lx is greater than 2, it is considered as a one-way slab. When Ly by Lx is less than 2, then it is considered as a two-way slab. Okay, so detailing criteria as per IS 456 2000. What detailing criteria needs to be taken care when we are designing any type of structural element? See, if you refer IS 456, they have given various exposure conditions. So from as per exposure condition, we have to provide the nominal cover to that particular element. So this is the table which is from IS 456. So exposure, if your exposure condition is mild, then any structural element has a minimum nominal cover is 20 mm. If your exposure condition is moderate, then nominal cover is width requirement, depth requirement is 30 mm. If exposure condition is severe, then 45, and very severe, then 50 mm. Detailing criteria for slab as per IS 456. So what detailing criteria you have to keep in mind while you are detailing the slab? First is minimum reinforcement. So minimum reinforcement in slab is 0.12%. So 0.12% of total cross-sectional area. Example, your slab thickness is 150 mm, then you have to just 0.12 into 150, you can get the required mm square. That mm square has to provide in both the directions. So this criteria is not for only major direction or for main reinforcement, it is also for distribution steel. So minimum in slab 0.12% of total cross-sectional area has to fulfill. Now we will see the spacing of reinforcement. So for spacing of reinforcement, code has suggested that the maximum spacing of bar shall not be exceed 3D or 300 mm, which is smaller, whichever is smaller. Distribution steel spacing shall not be exceed 5D or 450 mm, whichever is smaller. D is the effective depth of the slab. Maximum diameter of bar. So code has suggested that you cannot provide a bar diameter if it D by 8 is the limit. The maximum diameter of bar in slab shall not exceed D by 8, where D is the total thickness of slab. So you have to keep in mind that you cannot provide more than this limitations as per IS 456. So this is the to mute to mute. Okay, so this is the standard details which is given in SP34. So in figure 1, you can see that it is the bent up bar detail, and in figure 2 it is a straight bar detail, no bent up, it is a straight bar detail. Both details are applicable to site right now, and majority of places you can see that bent up bar is still everybody is using bent up bar more than this cut bar or straight bar detail. Both are allowed by code. So you can provide straight bar detail as well as you can provide bent up details. It is up to you. So both the details are right. So we have to understand what code has given, what type of detailing you have to take care for. Okay, we will start from this. Okay, for bent up bar, suppose this is the edge beam. So at edge beam, so from when you start from here, so your this center to center length, say L1, center to center second span length is L2. So they have given a standard dimension which we have to follow in our structural drawings. So for edge beam, you can say yours from center to this bent up distance is 0.15 L1. Okay, and from start it is should be greater than or equal to 0.1 L1. L1 is center to center distance between two beams. Okay, then this is your main steel reinforcement, and the dot is distribution steel if it is a one-way slab. If it is a two-way slab, then by default both direction it is the main steel, but inside you have to place your main steel in shorter direction first, and then another main steel in longer direction. So always try to keep your main steel in first layer. Okay, so so this is the bent up detail they have given. This is the edge beam. This is the intermediate beam. For in intermediate beam, your crank distance from this center line is 0.25 L1, and from face it is 0.3 L1. So all dimensions are given and freezed in SP34. We have to just follow this dimension. When we are designing the slab, we have to give each and every dimension in our drawings. I will show you the same. We have to give exact dimension from face, how much distance is there, from center, how much distance is there, where this crank will be started. So all dimensions you have to show in our standard drawing when you are detailing. Both the detailing are same. The only difference is there one detail is for bent up and another is for straight bar. Okay, so this is the detailing of one-way slab. So when we are talk about one-way slab, so in shorter direction we can so the slab is spun in this way. So your main reinforcement will come in shorter direction. Okay, so you have to put first this reinforcement and then distribution reinforcement in longer span. Okay, so they have given a section in very clarity. So they have provided first bent in bent up steel there are various methods. You can show both bent up steel like this, and one straight bar. So one straight bar, one bent up steel, one straight bar, and one bent up steel. Otherwise, you can also provide like this, which code has suggested, your one side one bent up only. So your one reinforcement, one bent up will here, and another reinforcement, another bent up will be here. Or I have, as previously said, you have two options. Either you can provide like this, or you can just bent up this steel, okay, and another reinforcement will be straight bar, straight away straight bar. Okay, both are acceptable. Now we will going to this. Okay, this is the two-way slab detail. In two-way slab, as slab Ly by Lx is less than 2, slab is transfer their load in both the directions, and but you have to keep your reinforcement first in shorter direction and then longer direction. Okay, so that you have to clearly mention in detailing or in the drawing. So they have even if your 4 edge is discontinuous, they have given the dimension of curtailment where the bent up bar will start. So 0.1 Lx, 0.1 Ly. So it is very easy, but this is only for 4 edge continuous slab. When there are continuous slab or when there are number of slabs, then you have to choose various slab edge condition as per IS 456 for two-way slab. They have, which is covered in design process, but this is the only ideal standard slab design where they have mentioned 4 edge discontinuous. Okay. So this is the corner. This is the very important. That's why I have included in this our slide. This is corner or torsion steel detail for two-way slab. What happened when this slab will deflect? Then all corners needs some restraint. Otherwise, it will create torsion. So that's why at discontinuous edge, that's why we have to stiff the corner to avoid cracks. If you will not provide torsion steel in all corner, as all edges are discontinuous, definitely you have crack, visible crack at side. You can see that. So that's why it is much important that please do not forget to provide torsion steel in two-way slab, and specifically for all corners or for where two edges are discontinuous basically. So this is so you can say this is one edge, this is one edge, this is discontinuous edge, this is discontinuous edge. So both edge are discontinuous, and for both, and when both edge are discontinuous, you have to provide a corner steel like this way. You can provide CPR type reinforcement for this, and up to extent is Lx by 5 and Lx by 5. What is Lx? So then Ly is the major longer direction, Lx is the shorter direction. If my slab width is 2 meter by 3 meter, then I have simply divided 2 meter 2000 by 5, and I have to provide minimum width of 400 mm, minimum width of 400 mm. So this is just example you have to follow when you are detailing two-way slab, and specifically for when both edges or both edges are discontinuous. Okay, so another detail is that, okay, what area, so when okay, how to decide how much reinforcement is covered here. So as per code, AST, what is the maximum AST you have provided in top? What is the maximum? See, in shorter direction you will always get the maximum reinforcement. So that maximum reinforcement provided into 3 divided by 4 means 3 by 4 of AST provided. That area has to provided in top and bottom. So they have shown that 3 by 4 of AS is AST provided, not required. This is AST provided. Okay. The same way they have given another detail in code. When both, see, one edge is say, just a minute. say one edge is discontinuous, then also you can provide this torsion steel, and for that they have reduced the steel, and the requirement will be 3 by 8 of AS. Okay, the extension will be same, Lx by 5 and Lx by 5. Here one edge is discontinuous, here two edges discontinuous. Okay, now okay. Okay, I will also I also want to share you the cantilever slab detail, because cantilever slabs are very important, and normally cracks are developed majorly in cantilever slabs only. So detailing aspect, cantilever slab detailing is very much important. The back anchorage is very much important. You have to provide minimum L as a back anchorage. Normally, for good practice, we can say we will provide 1.5 times the L. What is the L? Suppose my L, this is the L. See, if cantilever projection is say 1 meter, so I have to in the top I will extend that steel up to 1.5 meter, at least L, but as a good practice you can extend up to 1.5 L, because if you want, because it requires anchorage. Back anchorage is must for all cantilever span slabs. Okay, and another important thing which is not covered in this code, but in free edge, this is the free edge. In free edge, you have to provide a camber. What is camber? So you have to just slightly uplift this slab. Okay, you have to slightly uplift this slab. So inside, what they are doing, they are arranging props in such a way that, suppose you have written that 10 mm camber at free edge. So what it means? So see, in we have two type of displacement. This is short term displacement and long term displacement. So when long term deflection will be creep, shrinkage and temperature will cover. So at later stage, if slab will be deflect, then this slab will be now in your exact position. So what you are doing right now, by construction stage itself, you will uplift this slab by 10 mm, 15 mm or 20 mm, so that in future you can avoid cracks issue. Okay, because in later stage, you can say 5 years, 10 years, definitely for creep, shrinkage and temperature effect, this slab will be deflect more other than this simply supported or continuous slab. So whenever you design a cantilever slab, you can say span greater than 1 meter, not less than 1 meter, but greater than 1 meter. It is always good practice to have a camber at free edge. And another good practice is that just extend your top steel up to 1.5 L as a back anchorage. So you will never face any problem in future for cantilever slabs. Okay, the another detail is, if your slab thickness is only 75, if architecture wants very less thickness in at edge of this slab, so you can straight away avoid the bottom reinforcement. You have to just provide a top reinforcement. Okay, here why we have to, okay, just I will if my top reinforcement main requirement in cantilever slab is that in top, so tension will be generated in top only. In bottom you have to just provided minimum reinforcement whatever. So suppose your top reinforcement is 8 torr at 100 center to center example, in bottom only 8 torr at 200 or 8 torr at 250 center to center you have to just provide, because in bottom no tension will be there, just in top tension will be there. So you have to focus at top only. Okay, now we will, just a minute. Okay, why I have just kept this image, because when you came in this final after college, when you came in this field, our structure engineering field, you can see that very odd shaped buildings and very odd shaped slabs you have to design. So when there are re-entrant corners or re-entrant slab is there, you have to provide additional steel at all re-entrant face, because maximum local stress concentration will be high or twisting of slabs will be there. So definitely due to more stress, due to local concentration, to avoid crack in future, you have to provide additional steel, and code has already given the length of this bar. The length of this bar is 80 times D. What is 80 times dia is, means phi is the you can say so my reinforcement dia is 12 mm, so simply 12 into 80. So you have to just when you are dealing with this type of slab, you have to provide re-entrant additional steel for re-entrant edges. Okay. Now, okay, additional steel near cutout area. So there are so many cutouts when see in final layout for any type of building, there are NEP services okay going from slabs. So there are so many sleeves cutout. There are so many other pipes cutouts in slabs. So you can provide cutout in slabs, but you have to provide additional steel. Otherwise, due to that cutout, definitely cracks will be generated. So that's why code has suggested, if your cutout dimension is greater than say 200 mm, then you have to provide additional steel like this way. Suppose my cutout is like this, is square cutout is there or circular cutout will be there, then this type of arrangement has to provided in your detailing point of view. Okay. Okay, so this is the actual site images of slab. Okay, you can see that this is the continuous slab, this is the beam, this is the column, and you can see these are covers. Okay, at span and at support, the reinforcement you can see. So here in one image, this is first image. In first image, you can see that this is the cut bar type detailing. No bent up is provided. Okay, this is the cut bar type detailing. Okay, straight bar type detailing, and this is the bent up detailing. So here you can see the bent up bars. Okay, and here this is the straight bar. So another images are there. Okay, beam is there, columns or shear walls are there, and here this type of arrangement you can see. Okay, and this is also another image where you can see the large span slabs, either two-way or either one-way. Majorities are two-way slab. You can see here this slab's width is less, so this is the one-way slab, and these two are two-way slab, and this detailing is like this. So this is the actual site visit pics. Okay. Okay, so slab chapter is over. Okay, just for 2 minutes, I will just back. Okay, we have started. We have started mainly two types of slabs, one way, two way. Then we have seen the nominal cover requirement. We have seen the minimum reinforcement required, which is 0.12 percentage, and we have seen the maximum spacing required, which is 300 mm, and diameter of bar you cannot exceed d by 8. Okay, so this is the standard slab detail which you have to follow from SP34. Okay, and this is the one-way slab detail, this is the two-way slab detail, this is the torsion steel. Very much important detail. You have to provide this detail at all the corners while two edges are discontinuous. Then we have seen the cantilever slab details. Then we have seen the re-entrant slab additional steel detail, and lastly additional steel detail near cutout. Okay. Okay. Now we are moving in RCC beam. Okay. So it is a structural element which resists applied load on the respective beam axis. Beam axis means either in major direction or either in minor direction. Shear force and bending moment produced at support by applied loadings, and which in turn into induced internal stress, strain and deflection of the beam. It is a flexural member and mode of deflection is governed by bending. So type of beams characterized by one according to support condition and according to shape of beam. So according to support condition, you can see that if this is the A figure, this is a cantilever beam. One edge is fixed and another is free. This is a pure cantilever beam. Another is simply supported. The C is overhanging. Okay, balance cantilever. You can. This is overhanging. So this balance cantilever. This is cantilever. This is cantilever. This is overhang beam. Continuous beam. This is fixed and both edges are fixed, and this is cantilever or simply propped cantilever. You can say. Now, according to shape of beam, you can say T beam or L beam. L beam is there and T beam is there. So, according to its shape, the name of beam is T beam or either L beam. So, if we are going into steel, this is the I beam, channel beam. So, this I have just put image. Okay, the important part is this: beam detailing criteria as per IS 13920/2016. Okay. So there are total 4 types of criteria. One criteria is for size. Another criteria is for longitudinal reinforcement. Longitudinal reinforcement means main reinforcement. Third criteria is for splicing. Splicing of longitudinal bars. Splicing is very much important. What is splice? When you have to connect, because the maximum length of bar available is 11 meter or 12 meter. So after 11 or 12 meter, you have to just splice one bar with another bar. So this is the important criteria. And the fourth one is the transverse reinforcement. Transverse reinforcement means this is the stirrups. Okay. Okay. We are. Okay, we will start with criteria for size of beams. Okay, so there are basically 5 criteria for sizing. This is B, this is D, this is small d. Small d is after reduction of cover. First criteria is width by depth ratio should be greater than 0.3. You have to understand this is width by depth ratio should be greater than 0.3. If it is less than 0.3, then it will not categorize as a beam. Okay. The another criteria is minimum width of beam is 200 mm. This is also important criteria because before this 13920/2016, you can see that there are many consultant or many company will give the 150 or 115 mm thickness beam. Actually, which is not allowed as per IS 13920/2016. So you have to provide minimum 200 mm width of beam. The third criteria is depth should not be greater than 1/4 of clear span. Fourth criteria is the width of beam is less than width of column. See, this fourth criteria is width of beam is less than width of column. The code has mentioned this. I will come this point because this point is very important. Fifth criteria is width of beam should be less than 0.75 width of column. Okay, fourth and fifth point are very much important. I will cover it just a minute. Okay, this is the criteria for longitudinal bars. For longitudinal bars, code has given a various criteria. This image will explain in detail in next slide. Just a minute. Okay. Criteria for longitudinal bars: minimum 212 torr dia through at top and bottom has to provided. If this is beam, you have to provide minimum 212 torr dia at top and at bottom. Okay. The another is minimum PT percentage. So as per IS 456, the minimum percentage of beam longitudinal steel is 0.87/F5. But as per IS 13920 for ductility criteria, for ductility requirement, the minimum percentage of steel for beam is 0.24 under root of FCK divided by F5. What is FCK? This is the grade of concrete. What is F5? This is the grade of yield stress of steel, you can say. So all secondary beams, you do not require any ductility requirement, but for all main beams, you have to follow this criteria. So for all secondary beams, you can also provide 0.87. You can follow that IS 456 rule, but for all ductility beams for all mainframe beams, you have to provide this criteria. The minimum steel should be 0.24 under FCK divided by Fy. Okay. Third criteria is that maximum steel at any section should not be greater than 2.5% of total cross section area. Maximum steel at any section should not be greater than 2.5% of cross section area. So this is the upper limit of beam. 2.5% is maximum limit. Okay. Fourth criteria, support location, at least half the steel of top support shall be provided at bottom of support. What it means? Actually, see, suppose in top, I need 2000 mm square area in this support. I have to provide 2000 divided by 2 means 1000 mm square area at bottom. Though your software or your manual design will not show this reinforcement, but as per ductility requirement, you have to provide half steel at bottom. Okay. Then fifth criteria is longitudinal steel at any section shall be at least 1/4 of maximum AST provided at support location. Okay, what it means? See, the maximum requirement, say my maximum area requirement is 1000 mm square, 1000 mm square. So I have to provide through steel is equal to maximum provided steel divided by 4 simply. So 1000 divided by 4, I have to provide through bars at least maximum AST provided, not required. Remember, AST provided. So suppose AST requirement is 2000 mm square, I have provided 2500 mm square, then 2500 divided by 4, that I have to provide through in top, in bottom, both the way. Okay, so this criteria has to follow. These are basic criteria. I am again repeating. First criteria is 2/12 diameter through top and bottom. Another criteria for PT percentage 0.24 under root FCK divided by Fy. Third criteria is maximum steel at any section should not be greater than 2.5%. Maximum steel should not be, upper limit is 2.5%. Fourth criteria is support location, at least half the steel of top support shall be provided at bottom support. Okay, and the last criteria is 1/4 of AST provided. Okay, the third criteria is criteria for splicing of bar. So okay, when I will share you at which location splice has to provided, but this is the criteria is there. This when you provided splice, then distance between two stirrups should not be greater than 150 mm. You have to restrain the stirrup spacing. Okay, criteria for splice bar. Okay, done. The spacing of link over the splice should not be greater than 150. The spacing of link over the splice. See, minimum LD distance will be there. Okay, so so this stirrup spacing should not be greater than 150 mm. The another criteria is lap length shall be less than development length of largest longitudinal bars in tension. Lap splice shall not be provided within distance 2D from the face of column. Okay, what is the 2D distance? Okay, I will see. This is the confining zone. 2D is defined as a confining zone. It is actually in simple form. It is a point of contraflexure. So what is the point of contraflexure? Where you will get moment almost zero. So this is that point. So at 2D distance, up to 2D distance, this is your confining zone. So in confining zone, you cannot provide any lap. In top or in bottom, you cannot provide any lap. Lap splice shall not be provided within quarter length of the beam where flexural yielding may occur. This is the same. Not more than 50% of area, either top or bottom, shall be spliced at any one section. Okay, I will explain you. See, if you have provided 4 bars in top, 4 bars in bottom, so what is the criteria? You cannot splice 4 bars at a time at one section. So you can provide maximum two splice. Okay, two so one splice at one location and another splice at another location. So out of 4 bars, first 2 bars will splice, and then after that another 2 bars will splice. Location I will show you which is the ideal location for splice. Okay, so this is the confining zone, this is the non-confining zone, this is the confining zone. Okay, so in this you can see that in confining zone we will not provide the splice. Okay, and spacing of stirrups, now we will go with spacing with stirrups. Okay, first first we will go with simply supported beam detail. Okay, there are simply supported, continuous, then cantilever, all beams I will show you step by step. Okay, the main thing which we have to take care in simply supported beam is there. So suppose I have provided some through steel, and at we all know that due to WL square by 8 the maximum steel requirement is in the span, and but the extent of that additional reinforcement should be stopped at L by 7 and L by 7. Okay, so from this line to L by 7, from this face of beam to L by 7. Okay, first stirrup we will cap at 50 mm from the face of beam. First stirrup is from 50 mm. In bottom you can say I have provided encouragement, but in top I have just insert this steel LD by 3 or till beam cover. Why have? Because see, you are provided release in secondary beams. Okay, so your majority of moment will be taken care by your bottom span. Tension crack will be here. Okay, because you have just released this beam. Okay, so due to that no fixity is required at top. When you release your beam, when you release in my direction, when you release your beam in mz direction, then no need to encourage or no need to provide LD plus 10 times dB for this top bar. Just minimum encourage length is required. Okay, to behave this beam at site as a secondary beam. See, whatever your assumptions is there, the same concept you have to provide at site. So if you assume this is a pure simply supported beam, so you have to just take care that your top reinforcement just require minimum encourage LD by 3 or till beam cover. Okay, so this is the actual beam detailing of projects. So suppose 312 tor bar is here, 312 tor bar is here, and this is the section. The beam size is 230 by 600. So I have clearly highlighted that LD plus 10 dB is not required for this top steel. You have to just insert here LD by 3 or up till this beam face. Okay. Then single span beam with and column details. Single span beam with and column details. So see, this is the I have already told you that we will keep our first stirrups at 50 mm. We will keep our first stirrups at 50 mm. The stirrup spacing should be less than or equal to D by 4, 8 times dB or 100 mm. You cannot provide more than 100 mm in confining zone. You have to keep minimum 100 mm spacing. Okay, sometimes you are using 12 tor diameter, so it will around 96 mm, but you can play with in 4 mm, not an issue, but the requirement is 100 mm. Okay, so keep in mind, in confining zone, either you will provide 8 diameter stirrups or either you will provide 10 diameter of stirrups. You have to keep the spacing of 100 mm only. And what is this distance? So this distance is 2D or L by 4, whichever is greater. So 2D means the depth of beam, say 600 depth is there. So this distance will be 1200. Okay. or L by 4. See, if this beam is shorter, then 2D will govern. If this beam length is more, then L by 4 will govern. So suppose I have to detail 10-meter length beam. So in 10-meter, and that if depth of beam is 600 mm, so I have to choose L by 4 distance, not 2D distance. Okay, so 2D or L by 4, whichever is greater, up to till that is your confining zone. In confining zone, your stirrup spacing has to 100 mm. So this is your confining zone, this is your confining zone, this is your non-confining zone. Okay, this is the typical continuous beam details. This is the same column, 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 continuous beam, and the same criteria which I have explained earlier. This is the actual detail. Okay, how we will detail or how we will give beam reinforcement to client at site. So this is the, say this is the 216 tor plus 112 tor is through steel. In bottom 316 tor is through steel. So once I have provided through steel as per bending moment diagram, requirement of steel in span and in support. So I have provided the additional steel in span as well as support. And this is this 1400 is what? This is the L by 4 or LD, whichever is maximum. 1400 is L by 4 or LD. What is this 750? This is the L by 7. This is the L by 7. I have to curtail the bottom reinforcement, additional curtail bar. L by 7, L by 7. This is maximum of L by 4 or LD. 2D. This is the maximum of L by 4 or 2D. Okay. This is the confinement reinforcement. This is the confinement reinforcement, and in non-confining zone, I need T8 or 125 center to center. This is just example how we are detailing at actual practice. Okay, typical continuous beam with bracket. Okay, this is also important. So, like slab, if this length is L, you have to keep at least 1.5 L in as a back anchorage. Minimum criteria is as per code is L, but I prefer you just take this bar at least 1.5 L if possible, because cantilever beams or cantilever slabs are more prone to cracks at site at later stage, and camber is always keep good practice. Whenever you see any cantilever beam or any cantilever slab, at least 10 mm camber at free edge has to provide it. Okay, so this is good practice. Okay, so this is the actual detailing of one of project in which, see, this length is 1800, and as per code, L has to provided as a back anchorage, so top reinforcement extended up to 1.8 meter. Also, you can go beyond 1.5 into 1.8. You can extend this reinforcement to this, no issue. This is the good practice, and camber is always there at free edge. You have to just keep a note here, okay, and you have to just focus on back anchorage specifically for cantilever type of beams. Okay, when we are provide side face reinforcement. Okay, what is the side face reinforcement? When you have a beam depth greater than 750 mm, you need a reinforcement in sides. Okay, so code has given the criteria. That criteria is 0.1 percentage of wave area. Okay, so and the spacing between two bars shall not be exceed 300 mm. Okay, this is the actual detailing of side. See, the depth of beam is say 900 mm example, or more than 750. So I have to calculate 0.1 into, say my beam width is 230 mm and depth is 750 mm. Then 0.1 into 230 into 750, that mm square has to provided divide by 4. So why divide by 4? Because it has two face, means. So you will get the total number of bars. Okay, so you have to keep like this. 4 10 tor side face means 2 tentor at each face. Okay. Okay. Now, very interesting beam, coupling beam. What is coupling beam actually? So first I will show this figure. So you can see that figure A, figure B, figure C. When you have a shear wall with very small span beam, okay, when you have a shear wall very small span beam, when you have shear wall very small span beam, what actually happened, that it is a horizontal structural element typically made of reinforcement concrete or steel that is used to connect two columns or walls in a building. It is a primary function is to transfer load and stresses between the connected structural members, providing a strong and stable connection. Okay, in seismic prone areas, coupling beams play a crucial role in enhancing the building's resistance to lateral force, such as those generated during the earthquakes. They act as a link between the columns or wall, okay, allowing the structure, okay, to better withstand and distribute this lateral load. When I have to transfer my lateral load from one column to another column or from one shear wall to another shear wall, it will behave like a link. Okay, so coupling beam contribute to the overall stability of the building, especially in structures with large openings or discontinuities in the load bearing elements. They help maintain the structural continuity and prevent the local failures. See, there are many cases when you have to provide opening in shear walls, the door opening or some another big opening for window opening or door opening you have to provide in shear walls. So you can allow the opening but in only central span, because in shear wall when you consider maximum stresses will develop at edges, okay, in compression and tension, in the form of compression and tension. So you can allow the opening, but that after that opening, that beam will act as a link beam or coupling beam. Okay, so how we are detailing that beam? Okay, code has suggested this detailing for specifically coupling beams. So you can see that in addition to longitudinal steel and stirrups, you have to provide a diagonal steel. Okay, this is the very crucial part, because inside while placing this diagonal steel is very challenging. I will show you the image. Okay, so this diagonal steel has to provided. Why? Because to avoid cracks from that, from here, to avoid the cracks here, due to large shear deformation, tremendous force will be there in this beam, tremendous axial force will be there in this beam. So you have to provide diagonal steel to take care of that additional requirement. Okay, so this is the actual site image of coupling beam. Okay, you can see that there is no space for concrete, you can see that, but this beam will act as a link beam, or you can say coupling beam, and you have to provide this diagonal steel. Okay, now as I have conveyed you that when you are dealing with structural layouts, you will see that you have to coordinate with architecture, you have to coordinate with MEP consultant. What is MEP consultant? Mechanical, electrical and plumbing services. So for MEP services, they need sleeves, they need cutouts in RCC slabs as well as in RCC beams. So at which location we have to allow, and suppose any cutout is required in beam web area. So what code has suggested us? So code has suggested that suppose any client or any MEP consultant needs cutout in web area of beam, then we can allow, but we have to tell them you have to keep this face greater than 0.33d. What is 0.33d? Is small d. Small d is effective depth of this beam, means total d minus cover. Okay, then your face of this cutout will start at 0.33d. Okay, so how much extra reinforcement you have to keep? Okay, so code has suggested that stirrups to resist 1.5 times VU. Okay, this stirrup has to resist my actual shear force at this location into 1.5 times. So they have increased the limit. So you have to keep you have to ensure that your stirrups has to take 1.5 times your total shear force. This is VU, means ultimate shear force, that is factored one, not serviceability. This is factored load, factored shear. Okay, this is the flexural steel you have to provide just above this cutout. So flexural steel to resist moment is equal to 1.5 times 0.5 L0 into VU. This is nothing but force into distance, and so that's why they have multiplied 1.5 times with shear force, 1.5 times with moment. So from that moment you can easily find out the requirement of steel, but you have to keep into mind that that is amplified by 1.5 factor. Okay, these stirrups, side stirrups, this side stirrups which is complete like this is side stirrup. So side stirrups has to design for 2 times of actual factored shear force. Okay, first is this small stirrups has to design for 1.5 times VU. This large stirrups means the whole stirrups is designed for 2 times VU. This is 2 times VU, and the moment this flexural reinforcement has to resist 1.5 times your actual factored moment. Okay. Okay, typical detail of sleeve cut down in beams. This type of detailing we are share to client in our drawings. This is the standard detail that has to followed by all MEP consultant, because in some time what happened that you cannot ignore these sleeve locations, but majority you have to provided the standard details to your end user, and you have to just coordinate with MEP consultant that you have to plan your sleeves, the routes of pipes or the routes of ducts in such a way that my first sleeve location has to at where L by 3 distance. What is L by 3? This is nothing but this is the point of contraflexure where moment is very less, not zero I can say, but very less. Okay, so you have to provide your sleeve location, you have to provide your first sleeve from L by 3 from the support, from L by 3 from the support. So this is so see, if my length of beam is greater than 3 meter, I will allow maximum 2 sleeves, not more than 2. I will allow 2 sleeves. Okay, and that 2 sleeve location is fixed by us. Okay, because they are MEP consultant, they are mechanical engineers, so we have to tell them we cannot allowed in confined zone, we cannot allowed our any cutout, any type of cutout in confined zone. So you have to tell them, you have to convey them, this is our standard practice and you have to follow this. Okay, in any case, if due to some toilet area or due to some bathroom area, if they require some minimum size of sleeve, then we can allow them only sleeves which is less than 100 mm. Why less than 100 mm? Because as I mentioned in this slide, just a minute, as I mentioned in this slide that my beam spacing, the stirrup spacing is not greater than 100 mm. So if any sleeve which is less than 100 mm near in confined zone, you can allow 1 sleeve or 2 sleeve maximum in confined zone, but try to avoid them. But in unavoidable circumstances, you will understand at later stage, but at unavoidable circumstances you can tell them you can provide, but the sleeve should not be greater than 50 mm or 75 mm. Okay, so your sleeve can easily pass from that between 2 stirrups. Okay, so this is the standard detail of hook. So this is the we all know that 8 times diameter minimum or greater than 75 mm. This is, and this is 135 degree. You have to this is the very important, because when you visited any site, you can see that majority of bar bender is not following this detail, but when you go at site visit, you can see that some of contractors are there. You can see that these details are not following properly, but as a structure engineer, when we are go to site, and when we see that, you have to just make sure in that, okay, please follow this is the requirement of ductile detailing, and this is very important. Okay. Okay, this is the actual site visit photographs of beams. Okay, so you can see that this is some, I think this is a cantilever beam, this is back anchorage reinforcement, and the preparation is going on, where they make this beam cage first at above this slab area, and then after finishing this caging detail, they will lower down this cage in actual position. So all beams firstly just prepared and above the slab area, and then they lower down in actual position. Okay, so this is the another photos of beam. You can see that you can see the hooks, you can see this is a three-legged stirrups. You can see another side photos. Okay, so now we are go with this is the last chapter, RCC column. Okay, it is defined as a compression member who carries a direct axial load which causes compressive stress in element. Vertical element whose effective length exceeds 3 times least lateral dimension is called as a column. If the same compression carrying member is inclined, then it is called as a strut. Columns may be in various shapes like square, rectangle, circle, hexagonal. These are the 4 main criteria. First criteria is for sizing. Another criteria is for longitudinal steel. Third criteria is for transverse reinforcement, and fourth criteria is for spatial confinement reinforcement. Okay, so for sizing of column, we have only 2 criteria. First criteria is 20 dB. What is a 20 dB? If you have IS 13920 this is the figure from IS 13920 2016. They have misprinted this. It is a 15 dB, but actually, if you look into amendment, it is a 20 dB. Okay, so in amendment 1, they have clearly mentioned that please replace this with 20 dB. Okay, so 20 dB. What is a 20 dB? Okay. So this is very interesting because due to this, all architectures are very upset. I will explain you why. If you are using 12 torr diameter, so the minimum width of column in that direction is 12 into 20, means 240 mm width is required. If your reinforcement is 16 mm diameter, which you are using in beam, so 16 into 20, that is 320 mm. Okay, so when you are using 16 torr steel in beam, you have to ensure that your width of column is 320 mm. Actually, code has given this clause, but for 16 mm, it is not possible that inside they will provide 320 mm shuttering. So majority in all structural consultant practice, for 16 mm 300 mm is allowed. Okay, 320 it is next to impossible. For 20 mm, if you are using 20 mm dia steel in column in beam, then you have to ensure that in that direction your column width is 400 mm. Okay, so it is very much important that when you are designing or when you are model the any building, then you have to first ensure that the 20 dB criteria, because 20 dB criteria is already given by code and we have to follow. The minimum width of or minimum size of column is 300 mm. This has to provided, because in recent time also I have seen that many consultants are still using 230 mm width of column, which is not acceptable by Codal or any peer review consultant, because 230 mm width column is now absolute for zone 3, 4, 5. You have to provide 300 width of column. Okay. For longitudinal reinforcement, if circular columns are there, then minimum 6 bar you have to provide it. For lap splice, closed link shall be provided over the entire length over which longitudinal bars are spliced. The maximum center to center distance of stirrups over entire length of splice should not be greater than 100 mm. So when you are providing splice, your stirrup spacing should not be greater than 100 mm. Okay, because for column maximum majority of axial forces are there. So the splice location is wicker joint. So in wicker joint, you have to stiff that joint. That's why your length of splice should not be greater than 100 mm. The lap length in column shall not be less than development length of the largest longitudinal bar of the column. Okay. Lap splice shall be provided only in central half of clear column height. I will show you in the image, so you will get a better idea what I mean to say. Okay. So this is the criteria which is provided by IS 13920. The lap splice has to provide in central area of column. This is the non-confinement zone. This is the non-confinement zone. What is L0? This L0 is nothing but is at L0 is confined zone. This is confined zone and this is non-confined zone. Your lap has to provide it in central of this column area. Okay. Not more than 50% area of steel bar shall be spliced at any one section. This is the common for beam, slab, or you can see any structural element. Not more than 50% of area has to splice at one location. You have to, you can maximum go with 50%. Okay. Lap splice shall not be used for larger than 32 mm dia bar. For such bar, mechanical splices method is adopted in column. For transverse reinforcement shall consist of closed loops such as circular or rectangular links for circular or rectangular column respectively. The closed link shall have a 135-degree hook. This is a standard hook which is required for beam as well as for column. 135 degree is a standard with an extension of 8D. Okay, in IS 13920, they have mentioned 6 times D, but in amendment, it is now 8 times D, extension of 8D, 8 times diameter of bar, but not less than 75 mm. So, 8D or 75, whichever is maximum you have to provide. The minimum dia of transverse reinforcement is 8 mm. Okay, for 32 dia of longitudinal bar. For larger than 32 mm dia longitudinal bar, minimum dia of transverse reinforcement is 10 mm. If you are using 40 mm dia of longitudinal bar, then you have to go with 10 mm. For transverse reinforcement, the maximum spacing of ties is smaller of 300 mm center to center or half of the least dimension of the column. What is this? Okay, I will explain you. Okay, so for this link, okay, in non-confining zone, what is the spacing criteria? You cannot go beyond 300 mm or the minimum width of column divided by 2. Say my minimum width of column is 300 mm, then I have to keep 150 mm spacing between two stirrups. Okay. Okay. The cross tie shall be provided when the length of any side of links exceed 300 mm. Cross ties placed perpendicular to this links whose length exceed 300 mm. Alternately, a pair of overlapping links may be provided within the column. I will explain you. Okay. So see, this is the ideal way. See, this is the 6D or greater than 65 mm, but this is now changed to 8D and 75 mm. If you read, if you can see in the amendments, they have clearly explained for this. Okay, so this is the standard, the pattern they have shown for columns. Okay, the distance between two longitudinal steel should be less than or equal to 300 mm. You have to ensure that the distance between two longitudinal bar has to less than 300 mm. Okay, this is the same. This is the various types of transverse reinforcement detail which is mentioned in SP34. Okay, so if your distance between, okay, what it means, just a minute, I will explain you quickly. See, why they have not give stirrups here, why they have not given stirrups here, or why they have not given stirrups here, I will explain it. Because the spacing between two bar they have keep less than 75 mm. That's why there is no need to restrain this bar. They have to follow at every 150 mm your bar has to restrain. That's why they have provided detailing like this. Okay, this I have explained. This is L0 is confined zone, L0 is confined zone, and another is the non-confined zone where your lap will start. Your lap will start from H by 4. What is the H? H is clear height from this floor to this beam bottom. This is the H, not floor to floor height. Your height is from this floor to your beam bottom. Okay. This is the three-dimensional view of column and beam. Okay, spatial confined reinforcement criteria. Okay, so this spatial confined reinforcement criteria L0, we have seen this L0. So in L0, this criteria is that the larger lateral dimension of column or 1/6 of clear span or 450 mm. Okay, larger lateral dimension of column. If my dimension of column is 230 by 600, then I have to keep this dimension as 600 mm minimum, or h by 6. What is h? See, if h is 3 meter, so 3 meter divided by 6, that I have to follow. Suppose it is 500 mm, then my L0 dimension will be 500. Okay, not 450 or not. See, 230 by 600 is there, then 600 will be higher. Okay. The spacing of ties in confining zone of column and beam is not more than 1/4 of minimum dimension of column, 6 times diameter of the smallest longitudinal bar, and 100 mm. So you have to keep into mind that 100 mm is fixed for beam and 100 mm is fixed for column. Spatial confined reinforcement. When the point of contraflexure is not within the middle half of the clear height of the column, under the effect of gravity and earthquake load, spatial confining reinforcement shall be provided over a full height of column. Spatial confining reinforcement shall be provided over the full height of column which has significant variation in stiffness along its height. Okay, this is the standard photographs how we are detailing the columns. The reinforcement starts from foundation and then up to NGL I will provide throughout my confined detailing, and above grade slab level I will follow this L0 non-confining zone and then L0. So this is standard detail for if your column dimension is see in at suppose at bottom your column width is more and upper level column reduction is then you have to follow this type of detailing. Your vertical bar has to insert in lower up to 1.5 LD. Okay, and suppose sizes are reduction from both hand, then you have to follow the 1:6 slope and you have to continue this reinforcement like this way. Okay, this is also important detailing. This is the column steel termination at roof level. So at roof level, you have to curtail your vertical bar like this way. You have to your curtail bar this way. This is the roof slab. So in roof slab, you cannot cut bar at this face. You cannot cut bar at this face. Minimum from this to this end, your dimension should be LD. Okay. As per ductile detailing, it is LD plus 10 times DB. I have shown this figure as per SP34. Okay, this is the actual detailing, how we are showing our column detail to client. See, this is the foundation to plinth level schedule is there, plinth to ground floor schedule is there. So Z1, Z1 other and Z2, what is that? So see, suppose column dimension is 300 by 600 mm. So my first link, my master link is considered as a Z1 main link, Z1 others. The other link is considered as a these internal links. Okay, so how I will find out this main link? You all know that in IS 13920 they have specifically given the equations for this confinement, and for rectangle column, for square column, and then circular column. So from that equation we have to identify either 10 torr dia is required or either 8 torr dia is required as a master link. Okay, so this type detailing we have to show. See, here we are explaining the grade of concrete. This is the, suppose this column grade is M35. This is the grade of steel Fe500. This is the cover. In column we are use 40 mm cover, and this is the confining zone. See, from foundation to plinth level, you have to provide full confinement till plinth level. So confining zone is full length. You have to provide confined zone. From plinth to ground floor roof slab, you have three criteria. So larger dimension of column, another is 450 mm, and third one is h by 4. Okay, so out of that, the maximum criteria you have to mention this length. Okay, so this is the confinement ring, this is non-confinement ring. This is the actual photographs of columns. You can see that L0 and non-confinement here. Okay, so this is the closely spaced stirrups, spaced stirrups, and here is a where point of contraflexure is 0. This is the non-confined area. That's why the spacing is larger. Okay, this is the another image. You can see that the another important thing is that your beam steel has to inside the column, not outside the column. Your all beam bars has to pass from inside the column, not outside the column. Suppose your beam width and your column width is same. See, if your beam width is 300 mm and your column width is 300 mm, then you have to joggle this two bars, and then you have to keep them inside the main column reinforcement. Okay, that joggle should be that crank should be follow as per code, and that is in slope 1:6. This is the side images of column. Okay, so I think I have taken some 15-20 minutes more, but finally thank you for your attention. I think I have covered majority of detailing aspects of beam, column, and slabs. If you have any questions, then you can ask. Hello.
सर एक क्वेश्चन था सर, छोटा था।
बोलो बोलो।
सर अगर कहीं पे हिंज प्रोवाइड करना है, जैसे किसी भी बीम में, जैसे हमारा कोई प्राइमरी बीम है तो अटैच कोई सेकेंडरी बीम है, तो हमको जो हमारा एक्चुअल में जो हमारा कॉन्सेप्ट है डिजाइनिंग का वो ऐसा है कि सेकेंडरी बीम में हमारा हिंज बन रहा है। हम जस्ट सेकेंडरी बीम को प्लेस करना चाहते हैं प्राइमरी बीम के ऊपर। तो सर उसका एक्चुअल डिटेलिंग कैसे होगा? एक्चुअल में हम जब मॉडल करते हैं तो हिंज प्रोवाइड करते हैं, लेकिन जब डिटेल करते हैं तो उसको ऐसे फिक्स ही डिटेल कर, मतलब बहुत सारे डिटेलिंग में मैंने देखा है कि उसको लोग फिक्स ही डिटेल करते हैं।
यस, सही बात है। एक्चुअली जब भी आप कोई भी डिटेल, इसीलिए मैंने बोला है कि बहुत सारी डिटेल आपको ऐसी मिलेगी कि आपको टॉप में और आपको जो टॉप स्टील होगा वो टॉप स्टील में फिक्सिटी वो डेवलप करेगा। अगर आपने वो रेनफोर्समेंट को अप टू LD + 10 टाइम्स DB आपने एक्सटेंड किया है तो बेटर है कि उसको सिर्फ LD/3 मतलब LD/3 करके उसको सिर्फ अंदर सिर्फ उतना रख दीजिए। बिकॉज क्या होगा कि वो वहां से फेल होगा ना, या वहां तो ही वो हिंज फॉर्मेशन होगा और बॉटम में फोर्स ट्रांसफर होगा और वो एज अ प्योरली सिंपली सपोर्टेड बिहेव होगा। और आप जो प्योर हिंज की बात कर रहे हो तो प्योर हिंज में कैसा होता है कि आपको क्रॉस डिटेल देनी होती है। वो क्रॉस डिटेल इज वेरी डिफिकल्ट एट साइट। क्रॉस डिटेल मैं आपको अभी ड्रॉ करके मतलब मैं कृष्णा जी को भेज दूंगा कि you have to just you imagine that your vertical steel, your through steel will be like cross detail। आपको क्रॉस डिटेल करनी है। अगर आपने क्रॉस डिटेल की तब वो वहां पे हिंज फॉर्मेशन करेगा।
ओके सर।
ओके,
हाँ ओके, एक्चुअली सर मतलब एक्चुअली मैंने कई जगह नोटिस किया है कि लोग उसको मॉडल करते समय हिंज तो वहाँ पे लेके चलते हैं कि यहाँ पे हमारा जस्ट हिंज है सिंपली सपोर्टेड, और जब डिटेल करते हैं तो
सिंपली
क्या
सपोर्टेड,
पड़ता
या
है।
सिंपली सपोर्टेड में क्या है कि बेसिकली आपको आपका वर्टिकल फोर्स ट्रांसफर करना है, राइट? तो
यस सर, वहाँ पे कोई टॉर्सन नहीं आनी चाहिए ना।
वहां पे कोई भी, इसीलिए हम लोग सॉफ्टवेयर में क्या करते हैं, जस्ट आपको, या फिर मैन्युअल जब डिजाइन करते हो तब क्या करते हैं कि हम लोग जस्ट, पहले मैं सॉफ्टवेयर क्या बताता हूँ कि हम लोग उसकी दोनों डायरेक्शन की मोमेंट रिलीज कर देते हैं,
यस
मतलब
सर।
मेजर डायरेक्शन की मोमेंट और माइनर डायरेक्शन की मोमेंट रिलीज कर देते हैं। अभी
ओके सर।
वो रिलीज हमने सॉफ्टवेयर में तो कर दिया, लेकिन हम साइट पे क्या कर सकते हैं उसके लिए, कि वहां पे मैं ऐसा नहीं बोल रहा हूं कि प्योर हिंज बनेगा, लेकिन टूवर्ड्स उसका हिंज जैसा फॉर्मेशन होगा।
यस
आर यू
सर।
गेटिंग?
यस सर।
क्योंकि आप टॉप स्टील को, आप बीम आप आपको आप टॉप स्टील को जस्ट ऐसा मेन रेनफोर्समेंट के बाहर नहीं छोड़ सकते। आर यू गेटिंग माई
यस सर।
पॉइंट?
यस सर। यस सर।
इसलिए मैंने आपको क्या बोला कि आपकी प्योर फिक्सिटी डेवलप ना हो,
यस।
इसीलिए आपको मिनिमम एनकरेज देना है। आप जितना मिनिमम एनकरेज टॉप में दोगे, वो टूवर्ड्स हिंज जैसा भी होने का ट्राई करेगा।
ओके सर, थैंक यू सर।
Okay, is there any question from another?
सेकेंडरी बीम। तो सर सेकेंडरी बीम में जो हमारा हिंज होता है नियर द सब, मतलब जहाँ पे जॉइंट होता है नियर द जॉइंट होता है, सो पॉइंट ऑफ कॉन्ट्रैक्ट फ्लेक्सर जो होता है वो थोड़ा पास में आ जाता है प्राइमरी बीम के। तो सर इन इस केस में हम क्या कर सकते हैं कि जो हमारा कन्फाइनमेंट है उसको कम कर सकते हैं? कन्फाइनमेंट जो आपने लेंथ बताई है 2D।
First of all, कि secondary beams are not designed for ductility. Okay, secondary beams are designed as a ordinary only, and you have to follow only IS 456 code, not 13920 code for secondary beams, because they are just transferring your loads from slabs and to main reinforcement, main frame beams. So for secondary beam, you can provide 8 tor at 200 center to center, 8 tor at 150 center to center. There is no limitations of confinement, confined zone and non-confined zone for secondary beams. Secondary beams are detailed as a secondary beams only. No ductility requirement or no confinement requirement for secondary beams. We also just keep in mind that secondary beams are designed and detailed as a ordinary only. Ordinary, not ductile detail, just ordinary detail, which is mentioned as per 456.
Hello.
Yes.
Yes, sir. I have a doubt.
Yes. Tell me.
सर supposingly एक RCC पोर्टल फ्रेम की एक स्ट्रक्चर है, उसमें हो क्या रहा है कि जो गवर्निंग लोड है वो 1.5 डेड लोड एंड लाइव लोड का केस है। मतलब कि अर्थक्वेक्स इतना गवर्न नहीं कर रहे, जो बेंडिंग मोमेंट डायग्राम जो हमें जिसके लिए फाइनल डिजाइन तैयार करना है वो 1.5 डेड लोड और लाइव लोड का केस है। उसमें सर ऐसा है कि जैसे सपोर्ट्स के ऊपर जब टॉप के ऊपर हॉगिंग मूवमेंट आ जाएगी, बॉटम के ऊपर सैगिंग मूवमेंट होगी, जो पॉजिटिव मूवमेंट होगी।
स्पैन में होगी।
नॉट सर स्पैन, एक्चुअली एट दी सपोर्ट्स आई एम टॉकिंग कि टॉप वाला जो हिस्सा होगा वो टेंशन में होगा और सपोर्ट के पास जो नीचे वाला हिस्सा होगा वो कंप्रेशन में होगा।
एग्जैक्टली।
अब उसमें ये है कि जब हम एलडी को देते हैं, डेवलपमेंट लेंथ को प्रोवाइड करते हैं, टॉप वाले पोर्शन में तो हम टेंशन की 47D या 50D अकॉर्डिंग टू दी ग्रेड ऑफ स्टील हम दे देंगे।
As per grade of concrete and grade of steel, you have to find out which is already given in IS 456 code. So various type of grade, various encourage depth will be, encourage length will be there.
माय क्वेश्चन इज कि जब हम नीचे कंप्रेशन वाले को देंगे, जो 1.5 लोड का लाइव लोड केस है, उसमें नीचे वाला स्टील जो कंप्रेशन में है उसकी जो डेवलपमेंट लेंथ होगी वो हम एलडी देंगे या फिर एलसी देंगे?
ओके, गुड क्वेश्चन। लेकिन जस्ट मैं आपको बता देता हूं कि कोई भी बिल्डिंग में जहां पे जोन 3, जोन 4 और जोन 5 में आप जब डिजाइन करते हो कोई भी बिल्डिंग, देन यू हैव टू कंसीडर डक्टिलिटी रिक्वायरमेंट एज पर कोड विच हैज सजेस्टेड। भले ही आपका मतलब आप डेफिनेटली कभी भी मुझे टेलीग्राम में या मेल में आप मुझे आपका मॉडल और आपकी जो इश्यूज आ रही है कि वो गवर्न हो रहा है 1.5 DLLL में, यू कैन सेंड मी एनी टाइम, आई विल चेक इट आउट। लेकिन द मेन इश्यू इज देयर कि अर्थक्वेक को हमको भूलना नहीं है। क्यों हम टॉप और बॉटम में एलडी प्लस 10 डीबी देते हैं, मैं आपको रीजन बताता हूं। क्योंकि अर्थक्वेक एग्जैक्टली इट इज रिवर्सिबल। ऐसा नहीं है कि एक डायरेक्शन में अर्थक्वेक आएगा दूसरी डायरेक्शन में नहीं आएगा। जब एक डायरेक्शन में आएगा तो टेंशन टॉप में रहेगा, दूसरी डायरेक्शन में वो बॉटम में जाएगा। तो टेंशन तो मेरा इन एनी केस टॉप और बॉटम में है ही, और जहां पे टेंशन है वहां पे एलडी प्लस 10 डीबी फॉलो करना है। ओके, तो
टोटली अंडरस्टैंड योर पॉइंट सर। एक्चुअली में यहाँ पर प्रॉब्लम सिर्फ इस बात की है, जो SP34 में भी दिया हुआ है, जब हम LC कैलकुलेट करते हैं हम सिर्फ और सिर्फ स्ट्रेट लेंथ को कैलकुलेट करते हैं, L के बाद हम कोई लेंथ को कैलकुलेट नहीं कर सकते।
हाँ, लेकिन मैं वही बोल रहा हूँ कि SP34 जो कोड है वो कोड का मेन कंसेप्ट है ऑर्डिनरी फ्रेम्स। वी आर डीलिंग विद डक्टाइल फ्रेम्स, वी आर डीलिंग विद जोन 3, 4 एंड 5। सो जहां तक 1392 की बात है, आपके कोई भी स्ट्रक्चर्स में भले ही वो चीज गवर्न नहीं हो रही है, इट डजंट मीन के बॉटम में टेंशन नहीं आ रहा है। आप समझे मैं क्या बोलना चाह रहा हूँ? रिवर्सिबल केस में भी भले उसके अंदर थोड़ा सा टेंशन फोर्स आएगा, थोड़ी सी मोमेंट आएगी, भले वो गवर्न नहीं हो रही एज पर योर एक्चुअल लोड कॉम्बिनेशन समरी, बट टेंशन विल बी देयर। So if you are dealing this same issue in zone 2, suppose you are dealing any building in Bangalore example, तो आप 100% बॉटम में कंप्रेशन जैसा स्टील दे दो, टॉप में टेंशन की रिक्वायरमेंट है वो दे दो, इट इज 100% ओके, जो SP34 में मेंशन किया हुआ है। लेकिन अगर आप जोन 3, 4 और 5 में डील कर रहे हो तो आपको टॉप और बॉटम में 100% LD प्लस 10 डीबी देना ही है। देयर इज नो, आपके पास कोई चॉइस नहीं है
सर। वो ठीक है, मेन बात सिर्फ इतनी थी कि हम क्या करते हैं, ऊपर वाली बीम को भी L नीचे की ओर को मार देते हैं, नीचे वाला जो सरिया होता है उसको हम ऊपर को L दे देते हैं। तो होता क्या है, जो कोड में लिखा हुआ है, इवन IS 456 भी ये कहता है कि जब नीचे वाला जो स्टील है उसको हम L मारेंगे, और अगर वो कंप्रेशन में हुआ तो वो L का तो कोई फायदा ही नहीं है, वो तो कभी काम ही नहीं करेगा।
यस, आई एम टोटली एग्री विथ यू, मैं आपका पॉइंट समझ रहा हूं, लेकिन आप जो बोल रहे हो उसमें मैं ये कहना चाह रहा हूं कि आप अभी जो बिल्डिंग कर रहे हो वो कौन से जोन में है?
वो सर जोन 2 में है। एक्चुअली उसकी हाइट भी काफी कम है,
जोन 2 में है, 15 मीटर से अगर कम है तो आप वो बॉटम में सिंपली स्ट्रेट बार दे सकते हो एज पर इस कंप्रेशन रिक्वायरमेंट।
ओके
ओके, you can if you are dealing with zone 2, if you are dealing with ordinary frames where no ductility requirement has to fulfill, तो आप SP34 और IS 456 दोनों कोड को फॉलो कीजिए। उसके अंदर जहां पे टेंशन आ रहा है उसी में ही LD प्लस 10 डीबी दीजिए, जहां पे टेंशन नहीं आ रहा है वहां पे सिर्फ कंप्रेशन की जो लेंथ आ रही उतना दीजिए। ठीक है,
ओके। और सर एक मेरा दूसरा डाउट है, जो कैपेसिटी शेयर का डिजाइन IS 13920 में, सर उसको मैं बाईपास नहीं करना चाहता हूँ, बट मैं उसको प्रैक्टिकली फॉलो करना चाहता हूँ, तो मैं उसको कैसे फॉलो कर सकता हूँ? क्योंकि होता क्या है, जो नॉर्मल शेयर फोर्स की रिक्वायरमेंट है कई बार उससे 2.5 टाइम्स या 3 टाइम्स भी कैपेसिटी शेयर की रिक्वायरमेंट आ जाती है।
अभी आप जो वो 1.4 टाइम्स आपका जंक्शन वाली जो डिटेल की बात है उसकी बात कर रहे हो आप? 1.4 टाइम्स उनकी कैपेसिटी चाहिए उसकी बात कर रहे हो?
जो शेयर की कैपेसिटी होती है ना, स्वे टू लेफ्ट एंड स्वे टू राइट वाला, मैं उसकी बात कर रहा हूं।
ओके, तो उसमें आपको एग्जैक्टली इश्यू क्या है उसके अंदर?
सर जैसे उसमें होता क्या है कि एक नॉर्मल बीम है जो 10-12 फुट की है, उसमें होता क्या, जो सिंपल एनालिसिस से जो शेयर फोर्स आती है, जो मैक्सिमम शेयर फोर्स का एनवेलप बनता है, वो शेयर फोर्स जो होती है उसके लिए अगर मैं शेयर डिजाइन करता हूँ तो एक नॉर्मल सी एक रेगुलर स्पेसिंग आ जाती है, 8 mm की 6 इंच पे 7 इंच पे आ जाती है। लेकिन अगर उसको मैं कैपेसिटी शेयर के डिजाइन में कर लेता हूँ तो वही शेयर जो होता है वो 10 का डाया 5 में भी बन जाता है, 6 में भी आ जाता है। वो आई मीन टू से कि जो शेयर फोर्स के लिए मैं डिजाइन कर रहा हूँ वो ऑलमोस्ट 2 या 3 टाइम्स इंक्रीज हो जाता है।
ओके, अभी आप जोन 2 में हो?
No, this is not zone 2. This is I'm talking about zone 4.
Okay, zone 4. Yes. Okay. अभी आप जो डिजाइन कर रहे हो वो कोई सॉफ्टवेयर में कर रहे हो या मैन्युअल कर रहे हो?
मैंने सर उसको ईटैब्स में करके देखा, उसने मुझे शेयर की रिक्वायरमेंट, जैसे आप जानते हैं वो कैपेसिटी के अकॉर्डिंग बहुत हाई देने लग जाता है, 1500 mm² 1900 mm² पर मीटर के हिसाब से ऐसे देने लग जाता है वैल्यूज को। और अगर मैं उसको ऑर्डिनरी स्टील में कन्वर्ट करता हूँ, जैसे ईटैब्स में ऑप्शन है, वो सिर्फ आती है 800-900 mm², जो हम
ऑर्डिनरी
स्टैंडर्ड।
ऑर्डिनरी में हम कन्वर्ट इसलिए नहीं कर सकते क्योंकि हमको वो बीम को डक्टाइल रखना ही है,
बिल्कुल
वो
बिल्कुल।
डक्टाइल रखना है, और आप तो जोन 4 में जा रहे हो। तो जो कोड में वो क्राइटेरिया स्ट्रिंजेंट किया हुआ है उसका रीजन यही है कि जो मैक्सिमम फेलियर है, आपने भी देखा होगा, जो मैक्सिमम फेलियर है वो जंक्शन के आसपास हमेशा होते हैं।
हाँ,
तो
वहीं पर पासिंग एज बनेगी।
को स्ट्रॉन्ग करने के लिए, जंक्शन को स्ट्रॉन्ग करने के लिए कोड ने वो स्वे लेफ्ट स्वे राइट की कैलकुलेशन करके उसको मल्टीप्लाई करके एक मैग्निफिकेशन फैक्टर जैसा आता है, और आपका जो शेयर रहता है वो शेयर की कैपेसिटी बहुत आपको ज्यादा देनी पड़ रही है। तो उसका रीजन सिर्फ यही है कि वहां पे डक्टिलिटी वो चीज बढ़ा रही है। एक्चुअली फ्रैंकली स्पीकिंग, आप जितनी मोर डक्टिलिटी बढ़ाओगे उतना फेलियर में वो आपको वार्निंग नहीं देगा, वो वहां से फेल हो जाएगा। ठीक है, अगर वो चीज कोई ब्रिटल होती है तो आपको वो क्या करेगी, पहले वार्निंग देगी, स्ट्रक्चर आपको वार्निंग देगा। जहां पे हायर डक्टिलिटी है वो वार्निंग नहीं देता, वो वहां से फेल हो जाता है। तो लेकिन कोड ने ऑलरेडी वो चीज को सोच के वहां पे रखी हुई है, तो हम लोग उसको बाईपास नहीं कर सकते। और इटेप्स जो है वो डेफिनेटली वो चीज कैलकुलेट करके ही आपको स्टीरअप्स देता है। मतलब वो, क्योंकि आप ऑर्डिनरी इसीलिए नहीं कर सकते क्योंकि अगर आपने वो चीज ऑर्डिनरी कर दी तो मतलब आप डक्टाइल डिटेलिंग फॉलो नहीं कर रहे हैं।
बिल्कुल।
ओके, जैसे आपने एक बात की है तो मैं आपको दूसरी बात कर देता हूं। जैसे आपको भी पता है कि जैसे अभी एक वो क्राइटेरिया है कि आपकी जो कॉलम की कैपेसिटी है, वो कॉलम की कैपेसिटी जंक्शन पे जो आपके बीम्स आ रहे हैं उससे 1.4 टाइम्स हायर होनी चाहिए।
हाँ जी, बीम को बीसीसी।
ओके, तो उसके लिए आपने देखा होगा कि कॉलम में कितना हैवी स्टील आ रहा है, क्योंकि वो कॉलम को आपको इतना स्ट्रॉन्ग करना पड़ेगा। क्योंकि हम लोग अभी जो सोच है ना 13920 की, वो सोच ये है स्ट्रॉन्ग कॉलम और वीक बीम का कॉन्सेप्ट है। हमको कॉलम को स्ट्रॉन्ग रखना है और बीम को वीक रखना है। इसलिए अगर आपने स्टिफनेस मॉडिफायर अगर देखे हैं तो कॉलम का 0.7 हम यूज करते हैं और बीम का हम 0.35 यूज करते हैं, बिकॉज अर्थक्वेक के ड्यूरेशन में कॉलम स्ट्रॉन्ग होने चाहिए। बीम स्ट्रॉन्ग नहीं होगे तो चलेंगे, कॉलम इंटैक्ट होने चाहिए। ओके, सो आपका आपका जो आंसर है मैं यही देना चाहूंगा कि वो जो रिक्वायरमेंट है वो कोड ने स्पेसिफिक दी हुई है, आप उसको बाईपास मत कीजिए। जो कोड ने दिया है वही उसके हिसाब से आप स्टीरअप्स प्रोवाइड कीजिए।
पर सर जस्ट फॉलो अप क्वेश्चन, जैसे आपने बताया कि जैसे जैसे हम डक्टिलिटी को इंक्रीज कर रहे हैं, हम फेलियर भी एक तरीके का एकदम से फेलियर हम एक्सपेक्ट कर रहे हैं या उसको कह रहे हैं कि वो होगा, तो इज इट रियली गुड आइडिया कि हम डक्टिलिटी कर दें?
इसीलिए हम लोग क्या करते हैं उसके अंदर कि जैसे Fe500 और Fe550 हम अभी ग्रेड यूज करते हैं स्टील का, तो उसके अंदर हम स्पेसिफिक नोट्स डालते हैं कि हमको मिनिमम एलोंगेशन 16%, 18% चाहिए। वो जितना एलोंगेशन आप उसका बढ़ाओगे तो उतना आपको टूवर्ड्स ए ब्रिटल फेलियर जैसा वो होगा और आपको एक वार्निंग देगा। आप समझ रहे हो मैं क्या बोल रहा हूँ? एलोंगेशन का परसेंटेज, इसीलिए कोड ने एलोंगेशन का, अभी आप जितने भी स्टील मेक यूज देखोगे कि जैसे एसआर स्टील है या कोई भी स्टील की कंपनी देखोगे, और कोड में 2062 करके जो कोड है जिसके अंदर ये सारे मटेरियल की प्रॉपर्टी आप देख सकते हो, उसके अंदर क्लियरली मेंशन है ग्रेड वाइज उन्होंने Fe500 का कितना एलोंगेशन अलाउेबल, Fe500D, Fe550D का कितना अलाउेबल है। तो वो सारी चीज तो मतलब अगर एलोंगेशन कम होता जाएगा तो वो टूवर्ड्स हायर डक्टाइल होता जाएगा और वो हमको कभी भी वार्न नहीं करेगा, स्ट्रक्चर हमको वार्न नहीं करेगा, वो
सीधा
फेल हो जाएगा। इसीलिए अभी हम क्या कर सकते हैं कि कोड ने जो क्राइटेरिया दिया है उसको हम बदल तो नहीं सकते, लेकिन हम लोग एलोंगेशन स्टील का बढ़ा सकते हैं। तो जब हम लोग रिपोर्ट देखते हैं, जब रिपोर्ट हमारे पास आते हैं तब हम देखते हैं कि हमने अलाउेबल 16% का मिनिमम क्राइटेरिया रखा हुआ है, लेकिन एक्चुअली जब वो स्टील बार का जब टेस्ट होता है तो वो टेस्ट में आप देखोगे तो अप टू 20%, 22% तक वो लोग स्टील मैन्युफैक्चर वाले वो आपको रिजल्ट देते हैं, तो आपके लिए वो चीज अच्छी है, आपको स्ट्रेंथ भी मिल रही है और आप एलोंगेशन की लिमिट भी बढ़ा रहे हो, तो साइट पे उसका इफेक्ट मतलब एक्चुअल में आपको वो बेनिफिट उतना मिलता है। ठीक है,
ओके ठीक है सर, थैंक यू। आई विल बी कनेक्टिंग विद यू ऑन टेलीग्राम आल्सो।
हेलो सर।
आई नो।
हेलो सर, गुड इवनिंग सर।
यस गुड इवनिंग
सर डाउट था सर एक।
अरे बोलो ना, डाउट के लिए तो बैठे हैं, बोलो।
सर वो रेस्पॉन्स स्पेक्ट्रम हम एनालिसिस करते हैं ना सर ई टैब्स में, तो उसमें हम लोग खाली स्केल फैक्टर को सेम करते हैं ना सर EQX EQY में।
ये अलग टॉपिक है, लेकिन फिर भी मैं आपको आंसर दे देता हूं कि रिस्पांस स्पेक्ट्रम में आपको दो चीज ध्यान रखनी है। सबसे पहले आप कोई भी स्ट्रक्चर डिजाइन करते हो तब आपको डेफिनेशंस में आपको नॉर्मल अपना अर्थक्वेक डिफाइन करना होता है, और साथ में आपको अनस्केल्ड अर्थक्वेक डिफाइन करना होता है, जिसकी वैल्यू आपको डिफाइन करनी होती है, जो हम बोलते हैं IG/2R, जिसको हम इनिशियल स्केल फैक्टर बोलते हैं। तो वो उसके हिसाब से आपको डिफाइन, अभी ईटैब्स जो नए वर्जन्स है 18 के बाद वाले सारे वर्जन 18, 19, 20, 21, अभी तो 22 भी आ जाएगा, तो वो सारे वर्जन में अभी उन्होंने क्या किया है कि सिर्फ आपको G की वैल्यू एंटर करनी है, बाकी सब वैल्यू बाय सॉफ्टवेयर वो खुद ले लेता है, तो आपको G की वैल्यू सिर्फ एंटर करनी है, दैट इज 9810। so you have to just assign 9810 for initial scale factor, then you have to first run your model, and after that अगर आपकी बिल्डिंग में बेसमेंट है और वो बेसमेंट आपकी बिल्डिंग के साथ कनेक्टेड है, तो आपको अर्थक्वेक ग्राउंड से गिनना है। अगर आपकी बिल्डिंग में बेसमेंट नहीं है तो आपको बॉटम ऑफ फाउंडेशन से आपको वो चीज मैच करवानी है। तो मैं अगर कोई भी मेरा बेस शियर, मुझे पता है कि जैसे अर्थक्वेक का मेरा बेस शियर बेसिकली स्टैटिक और डायनेमिक में यही अंतर है कि स्टैटिक जो है वो स्टैटिक का बेस शियर जो रहता है वो ऐसा एजम्पशंस है कि आपका टाइम के साथ फोर्स की वैल्यू चेंज नहीं होती है। डायनेमिक में हमेशा टाइम के साथ आपकी फोर्स की वैल्यू चेंज होती जाती है, दैट्स व्हाई इट इज कॉल्ड एज अ डायनेमिक और रिस्पांस स्पेक्ट्रम एनालिसिस। तो आपको वो जो बेस स्केल करना है वो स्केल आइदर ग्राउंड फ्लोर पे और आइदर आपको फुटिंग के लेवल पे, फाउंडेशन लेवल पे मैच करवाना है। और आपको वो कैसे मैच करवाना है कि आपकी अर्थक्वेक की कुछ वैल्यू होगी, आपकी स्पेक्ट्रम एक्स मतलब रिस्पांस स्पेक्ट्रम की कुछ वैल्यू होगी, तो आपको अर्थक्वेक का जो भी फोर्स है डिवाइड बाय स्पेक्ट्रम का फोर्स, आइदर वो हायर आएगा और आइदर वो लोअर आएगा, उसके हिसाब से आपको वो चीज मैच करवानी है। ठीक है, ये थोड़ा सा टॉपिक और ये प्रेजेंटेशन से बाहर का है, लेकिन फिर भी आपको कोई और भी डाउट हो तो आप सभी को मैं बोल रहा हूं कि मेरा नंबर और मेरी डिटेल्स, मेरा लिंक्डइन प्रोफाइल आप कभी भी खोल सकते हो, देख सकते हो। मेरा नंबर आप बालकृष्णा जी से ले सकते हैं, और मैं आपको अभी भी बता देता हूं 9920993224, दिस इज माय नंबर। आप मुझे टेलीग्राम में कांटेक्ट कर सकते हो। ये प्रेजेंटेशन के बाद इट इज नॉट नेसेसरी कि भाई ओके सर ने प्रेजेंटेशन में बताया अभी मैं इनसे कांटेक्ट कर पाऊंगा नहीं कर पाऊंगा। आपको कभी भी कोई भी प्रॉब्लम हो, कोई भी लेवल का क्वेश्चंस हो, आई विल ट्राई माय लेवल बेस्ट टू रिजॉल्व योर क्वेश्चंस। ओके, तो आप टेलीग्राम में बहुत सारे स्ट्रक्चर्स के ग्रुप है, वो सारे ग्रुप्स में मैं इन्वॉल्व हूँ एक्टिवली, और लिंक्डइन में भी एक्टिवली हूँ, तो लिंक्डइन में भी आप मुझे फॉलो कर सकते हो। और बेसिकली ये जो प्रेजेंटेशन है मे बी कुछ लोगों के लिए ऐसा होगा कि उसको सब पता होगा, कुछ नया नहीं होगा, लेकिन कुछ लोगों के लिए इसमें से कुछ चीज वो अपने लिए ले सकते हैं अंदर कि भाई ओके हम डिटेलिंग में इतनी इतनी चीज ध्यान रखेंगे। ओके, बिकॉज यहाँ पे अंडर ग्रेजुएट कुछ स्टूडेंट्स है, यहाँ पे पोस्ट ग्रेजुएट स्टूडेंट्स है, और बहुत सारे मतलब कॉलेज के बाहर के भी लोग हैं। तो मेक श्योर कि ये प्रेजेंटेशन, ये पीपीटी मैं कृष्णा जी को मेल कर दूंगा, तो कृष्णा जी आप आपके स्टूडेंट्स को ये शेयर कर देना। और कभी भी ये पीपीटी में भी आपको कुछ इश्यू है, आप मुझे टेक्स्ट मैसेज, फोन, एक्चुअली क्या होगा कि एज मैं डेली मैं भी वर्किंग में हूं, तो मैं वीक डेज में मतलब वीकेंड्स में मैं आपका रिजॉल्व क्वेश्चन कर सकता हूँ। तो सैटरडे और संडे आप मुझे क्वेरी भेज सकते हो, आपकी कोई इश्यू नहीं है, ठीक है। और एक रिक्वेस्ट ये है कि आपको ये सेमिनार का आपको एक फीडबैक जो है, वो फीडबैक जैसा भी हो, आपको अगर लगता है कि नहीं ये बहुत ही बोरिंग सेमिनार था, तो आप डेफिनेटली लिंक्डइन पे भी वो आपके कमेंट कर सकते हो। आपको लगता है कि नहीं इंटरेस्टिंग था, तो आप लिख सकते हो, क्योंकि फीडबैक इज इंपॉर्टेंट। फीडबैक इज इंपॉर्टेंट फॉर ईच एंड एवरी इंडिविजुअल। तो नेक्स्ट टाइम मुझे क्या चीज ध्यान रखनी वो भी मुझे पता चले। सो स्ट्रेट अवे आपको जैसा लगा हो वो आप फीडबैक मुझे दे सकते हो, आइदर लिंक्डइन में आप टैग कर सकते हो या फिर वो उसके अंदर लिख सकते हो। तो फीडबैक इज इंपॉर्टेंट। सो कृष्णा जी, आप भी एक फीडबैक दे देना आपकी तरफ से, जो भी हो, जेन्युइन फीडबैक। आई नीड जेन्युइन फीडबैक। ओके, एनीथिंग, एनी क्वेश्चन फ्रॉम अदर्स?
यस सर, हेलो सर।
सर टाइम काफी ज्यादा हो गया। जो इनके क्वेश्चन होंगे ना, हमें चाह रहे हैं सर ये रिकॉर्डिंग हम कर लिए इसका जो सेशन हुआ है, तो अगर आपका कोई यूट्यूब चैनल हो या कुछ भी हो तो हम उस पर अपलोड कर देंगे। इनका जो भी क्वेश्चन होगा लोग उसमें कमेंट करेंगे, पूछ लेंगे, या फिर आपको पर्सनली पूछ लेंगे।
अभी तो
हाँ
अभी तो यूट्यूब चैनल नहीं बना है, लेकिन बना देंगे, कोई इश्यू नहीं है।
सर हम लोग ने एक चीज सर,
हाँ
हम लोग ने स्ट्रक्चर इंजीनियर किया है सर, फ्रेशर है हम लोग, तो क्या स्किल्स डेवलप करना पड़ेगा सर हमारे को? अगर
ये लास्ट क्वेश्चन रहेगा और मैं ये लास्ट आंसर है, ठीक है। एज अ स्ट्रक्चर इंजीनियर मैं आपको दो चीज बोलूंगा। आपका स्ट्रक्चर के प्रति जो डेडिकेशन है और कंसिस्टेंसी जो है वो आपको बरकरार रखनी है। दूसरा, आपके जितने भी बेसिक्स है, बेसिक्स से सिर्फ आप अगर जुड़े रहोगे तो आपको कोई हरा नहीं सकता। सिंपल है। आपको बेसिक्स के लिए क्या करना है, सिंपली आपकी जो बी के जो आपके कोर्स है, स्ट्रक्चरल एनालिसिस फ्रॉम स्ट्रक्चरल एनालिसिस 1, तो स्ट्रक्चरल एनालिसिस एक बार आप रिफ्रेश कीजिए। आपका शियर फोर्स बेंडिंग मोमेंट डायग्राम से आप रिफ्रेश कीजिए, क्योंकि फील्ड में जब आप आओगे तब आप मैक्सिमम यही फेस करोगे। बहुत लोगों को लगता है कि कॉलेज में पढ़ा रहे हैं, ये क्या काम में लगेगा, फील्ड में तो कुछ अलग ही होता है। ऐसा कुछ नहीं है। जो कॉलेज में आपको पढ़ाते हैं, जो बुक्स में दिया हुआ है, वही चीज हम रिपीट करते हैं यहाँ पे। तो कभी भी ऐसा मत मानना कि भाई कॉलेज में मुझे इंपॉर्टेंस नहीं देना है, यहाँ का कोई वेटेज नहीं देना है, क्योंकि वो जो पढ़ा रहे हैं ना, वही चीज एक्चुअल फील्ड में आपको कोऑर्डिनेट करनी है। तो मेरी रिक्वेस्ट ये है कि जैसे आप ऐसा मान लीजिए कि आपको गेट की एंट्रेंस टेस्ट देनी है, ठीक है। तो गेट की एंट्रेंस टेस्ट में आप तो सारे सब्जेक्ट करते हो, आप सारे सब्जेक्ट पर फोकस मत करो, आप सिर्फ स्ट्रक्चरल एनालिसिस और डिजाइन पे फोकस करो। इतने ही सब्जेक्ट का पहले फंडामेंटल क्लियर कर लो, और उसके बाद जितने भी वे है, जैसे मतलब टाइम्स, आपको अगर जॉब ढूंढनी है या फिर आपको कुछ अच्छी कंपनी में जाना है, तो आपको क्या करना होगा कि आपकी जो टेक्निकल स्किल के अलावा आपको सॉफ्टवेयर भी आने जरूरी है। ईटैब्स है, सेफ है, आरसीडीसी है, स्टैड प्रो है, बराबर। तो ऐसे अलग अलग सॉफ्टवेयर है, वो सॉफ्टवेयर भी आपको चेरी ऑन टॉप है, वो आपको एडिशनल एडवांटेज दे सकते हैं ड्यूरिंग द योर इंटरव्यू प्रोसेस। ओके, क्योंकि लोगों को सब रेडीमेड चाहिए। एग्जांपल, आज मैं मेरी कंपनी में मुझे कोई बंदा लेना है, आई विल ऑलवेज गिव मोर प्रायोरिटी टू टेक्निकल नॉलेज। बट ऐसा जरूरी नहीं है कि मैं जो सोचता हूं वैसे सब लोग सोचे। दूसरे ऐसा भी सोचते हैं, नहीं टेक्निकल कम होगा तो चलेगा, मुझे सॉफ्टवेयर में इसकी मास्टरी है, तो मैं सॉफ्टवेयर वाले बंदे को पहले अपॉर्चुनिटी दूंगा। तो बेटर है कि पहले आप टेक्निकली साउंड हो जाओ और बाद में आप सॉफ्टवेयर सीख लो। सॉफ्टवेयर आराम से आप YouTube चैनल से सीख सकते हो, या कोई क्लासेस ज्वाइन कर सकते हो, या ऑनलाइन कोई क्लास ज्वाइन कर सकते हो, ठीक है।
थैंक यू सर।
ओके, थैंक यू बालकृष्ण अगेन, एंड आई होप जो कुछ आप लोगों ने कुछ तो नया आज सीखा है। तो बेटर है कि हम लोग कनेक्टेड रहेंगे। आपको कभी भी कोई भी इश्यू हो, यू कैन आस्क मी एनी टाइम, यू कैन टेक माय नंबर फ्रॉम बालकृष्ण, एंड माय लिंक्डइन इज देयर, you can just follow me and you can just raise your question anytime.
Thank you, Mr. Talsaniya, for your insightful presentation. We had a very meaningful session.
Thank you. Okay,
so much,
bye.
सर आपका जो टीचिंग का तरीका है, आपका नेचर काफी सही है सर। सर हमें लगता है कि इससे बहुत लोगों को बहुत ज्यादा फायदा मिला अभी और होगा भी।
नहीं, वो मैं एक्चुअली आई थिंक लोगों को पता नहीं होगा, लेकिन मैं सिर्फ बी ग्रेजुएट हूँ, मैंने सिर्फ बी किया है, मैंने मास्टर्स नहीं किया है। मैंने 16 साल पहले बी किया था, लेकिन मेरा डेडिकेशन और मेरा जो स्ट्रक्चर के प्रति जो अटैचमेंट है, वो मेरा पैशन है। तो ऐसे ही सब लोग जब स्ट्रक्चर को अपना पैशन मान लेंगे ना, तो मुझे 16 साल पहुंचे आईआईटी में लेक्चर देने के लिए, लोग 5 साल में पहुंच जाएंगे। तो बेटर है कि मैं लोगों को यही मेरी तरफ से एक सजेशन दूंगा एज अ बिग ब्रदर और एज अ यू कैन से बड़ा भाई और सर, कि आप स्ट्रक्चर के प्रति इतने डेडिकेटेड हो जाओ कि आपको कहीं जाने की जरूरत ना पड़े, आपको लोग बुलाएंगे। बस इतना मैं जानता हूं, आपका डेडिकेशन इतना रखिए स्ट्रक्चर में कि आपको लोग बुलाने चाहिए। बस दैट्स इट। थैंक यू।
थैंक यू सो मच सर।
थैंक यू। ओके ओके, बाय।
बाय, गुड नाइट
ओके,
सर।
थैंक यू।
गुड नाइट, गुड नाइट।